Suppose x1 and x2, these are two independent variates. Okay, let's say these are also uncorrelated variates. Fine. And the variance of x1 is, say, sigma 1 square, and variance of x2 is, say, sigma 2 square. Clear? And there are two other variates which are dependent upon these two variates, y1 and y2. y1 is x1 plus x2, and y2 is x1 minus x2. Now, you need to find out the correlation coefficient between y1 and y2. Let's see how. Note that these are uncorrelated variables. x1 and x2 are uncorrelated variables. So, how do you find out the correlation coefficient between y1 and y2? See, whatever you have to find out first of all, always write the formula for that. So, the correlation coefficient between y1 and y2, let me write it here like this. It should be covariance of y1, y2 upon variance or standard deviation of y1 into standard deviation of y2. Clear? Now, first of all, let me find out what is the standard deviation for y1. Standard deviation of y1, or I should rather write it in this way. Your y1 is x1 plus x2. What is the variance of y1? It will be variance of x1 plus x2, which will be variance of x1 plus variance of x2 plus 2 covariance x1 x2. Okay, now variance of x1 is sigma 1 square, variance of x2 is sigma 2 square, and these are uncorrelated, so this is equal to 0. So it is sigma 1 square plus sigma 2 square, that is the variance of y1. Okay, similarly y2 is x1 minus x2. Let me see if that is there now. Yeah, it is x1 minus x2. What is variance of y1? It will be variance of x1 minus x2, the formula for which is variance of x1 plus variance of x2 minus 2 covariance x1 x2, which is sigma 1 square plus sigma 2 square minus 0, because these are uncorrelated and independent variables. And so variance of, sorry, this is y2. It is sigma 1 square plus sigma 2 square. This is the variance of y2. Is that right? The variances are same in both the cases. Huh? So this is the variance of y1, this is the variance of y2. Now, so what about covariance? Covariance of y1, y2, it will be given by E of y1 minus y1 bar into y2 minus y2 bar. Okay, now what is y1? It is x1 plus x2. What is y1 bar? x1 plus x2 bar. Let me just write it here for you guys. y1 is x1 plus x2. y1 bar is x1 bar plus x2 bar. y1 minus y1 bar is x1 minus x1 bar plus x2 minus x2 bar. Similarly, you can write y, y2 is given as x1 minus x2. y2 bar is given as x1 bar minus x2 bar. y2 minus y2 bar is given as x1 minus x1 bar minus of x2 minus x2 bar. So you can substitute these values here. What you'll be getting is E of, in place of y1 minus y1 bar, you can write x1 minus x1 bar plus x2 minus x2 bar. In place of y2 minus y2 bar, you will write x1 minus x1 bar minus x2 minus x2 bar. Okay. So what will you have is x1 minus x1 bar square x1 minus x1 bar into minus of x2 minus x2 bar. So let me write this as minus x1 bar into x2 minus x2 bar plus x2 minus x2 bar into x1 minus x1 bar, which could be written as x1 minus x1 bar into x2 minus x2 bar plus, minus x2 minus x2 bar square. Okay, this and this will get cancelled out. What is E of x1 minus x1 bar square minus E of x2 minus x2 bar square? It is E of x1 minus x1 bar square minus E of x2 minus x2 bar square. This is what you will have. Okay, I hope I have done it right, isn't it? Minus there, yeah, because this is coming out to be equal to 0. So I hope that I'm doing it right. Yeah, I think I'm doing it right, but in case if I'm doing it wrong, please give me a comment that there is some algebraic mistake. Okay, so well, this will come out to be probably, see, this is nothing but variance of x1 and this is nothing but variance of x2. What is variance of x1 you've just found out, which is sigma 1 square plus sigma 2 square. What is variance of, no, variance of x1 is sigma 1 square and variance of x2 is sigma 2 square. Oh, sorry. So I was a little confused. I'm so sorry. So it is sigma 1 square minus sigma 2 square. Okay. I was taking x1 as y1. I'm so sorry. So it is sigma 1 square minus sigma 2 square. This is given to you. Okay. Now, what is the formula for correlation which you have? So correlation is R covariance xy upon sigma x into sigma y. What is covariance of xy? You've just found out. Well, I should not be writing covariance of xy. It is a little wrong. Covariance of y1, y2. Okay. Upon sigma y1 into sigma y2. Is that right? Or you can write sigma square y1, sigma square y2 root. And this is what we'll do. So covariance of y1, y2 you guys have found out, which is sigma 1 square minus sigma 2 square upon root of variance of sigma y1, which you have just found out, sigma 1 square plus sigma 2 square, and variance of y2 is sigma 1 square plus sigma 2 square. So it is square. So on simplification, this will come out to be like this. Okay, so this is the correlation coefficient between y1 and y2.